Okay, good evening, everyone. How are you? Can I see your faces? Okay, we just wait for 2 more minutes for the other students to come in. Yeah, we are 2 minutes before 8. 2 minutes to 8. Today we have a quiz. Yeah, we have a quiz. But I will explain how does the quiz work first. It is actually a discussion. It is a case study discussion. You will have a total of there are 10% marks for it, but 3 are in the form of quizzes, and then you have another 2.5% marks in the forum. So you're right, in forum we'll give them 2.5%. And then in the quiz, we have case studies. Today we'll have the first one. We will have, actually, it is a participation mark. So I will break you into groups. I will break you into groups. We will use breakup rooms to break you into groups. So in the group, you will discuss a topic. Actually, I've given you in the, there is a quiz at the LMS. There is a course, there is a case study that you need to go through. There is a question that you need to discuss among your friends. Yeah, we'll break you into group, maybe 4 or 5 person in the group. And then from the discussion, I'll give you half an hour or 45, I think say 45 minutes, half an hour. Maybe we'll just do half an hour. If you require extension of period, just tell me. And then I'll call you back, and then every team will share their point of view. So you appoint a representative among your group to answer the questions that we have that have been put up in the quiz. And then everyone take note of the answer. And then you will have to submit it latest on the 26th July. You only do one page minimum, 2 page maximum. Minimum 1 page, maximum 2 page. You don't have to do lengthy articles and so on. Just this is a participation mark. So we want it is an activity mark, but I call it quiz. Yeah. Okay. I hope everyone is here. So I will repeat. Okay. Let our friend come in first. Okay. I'll show you what we have in our LMS first. Let's see. I think I've done this last week. Just repeat again. Okay, this is the LMS. I put up an introduction for the course. So at the lesson, okay, you can see at the lesson, we have, there is a book. The book is here, the study guide and module. This is the module, the book. And then we have an e-book here. We have 2 books. It's the same book. One is the 4th edition, and then this is another global edition. They are the same book. Yeah, you can use it for your reference. And then for lesson 1, this is the lesson last week. This is the class link last week, and at the class link you can find the last week's and previous class tutorial, previous class tutorial video. Yeah, you can find it there. And then
prescriptions is a help.
And then this is I show you how to install R. Everyone needs to install R because next week we will start using R. I will explain how to use R next week because today we have quiz, so I don't have time to go through R today. But next week we will use R. And then I lecture for topic 1. This is the lecture for topic 1. So you go through the lecture on your own, and then this is the topic notes for the last week, and the topic notes for last week in PDF format. Okay, for this week, lesson 2, the topic note is already here. This is this week's note. So I will not be able to go through because we are short of time. And then, okay, this is class link. Later on, I will put up our class class record here, and then I lecture for topic 2. Okay, we will go through the topic 2 after our quiz, but I wouldn't have be able to go through all. So the rest of it you will go through on your own. Yeah, bear in mind this is online and distance learning, meaning that you are doing self-study. And then this is the case study quiz for today. Today we have a case study. You need to do an article. You can get this article from this link. And anyway, I also provide you okay, there is this link here. Okay. And then actually, okay. This is the article. Okay, there are 2 points. There are 2 positions that you can find this article. One, you can get the article from this link. So you need to read this article and then discuss with the group on the following. What problem is being addressed by applying predictive analytics? Remember, we talked about predictive analytics last week. So what is the problem that is being addressed by predictive analytics? And then what is in the case study is about FICO medication adherence score. So you read the article and then what is FICO medication adherence score? And then how does a prediction model is trained to predict the FICO medication adherence score? And then how did the prediction model classify FICO medication adherence score? And then you look into figure 4. Figure 4, it is in the article. I'll show the article later. Explain what kind of technique is applied on the generated result and list some actionable decisions that were based on the prediction results. And then you present your discussion. After, I'll give you maybe 40 minutes to do. Good. I think, I hope 30 minutes is enough for you. 30 minutes is enough for you, half an hour. And then after half an hour, you come back. We will regroup. Yeah. During this discussion, you will be in breakout rooms. I will break you into groups. And then we'll come back. And then you present your discussion point, very quick discussion point, each group. You appoint your rep to present, and then you prepare your individual answer in 1 page or 2 pages, and you are supposed to submit on the 26th of July. Okay, this quiz is available here at the lesson 2 at the bottom, case study quiz 1. It is also available here at the quiz. Yeah. At the quiz here. So, okay. This is the case study quiz 1. From here, you'll be able to download the quiz 1 PDF here, the attachment. It's the same thing. This is the case study quiz 1, the same question. This is the link. You can get the link from the case lesson 2 just now. And then this is the question that you need to discuss. And then this is the case study that you need to read. Yeah, you can the attachment in PDF is there, and then you will submit it here. Yeah, you will submit it here later. The deadline is 26th July. You have 70 days more to do. So next week we will not have quiz. We have 1 quiz, 2 quiz, and then we have 3 quizzes. Yeah, we have 3 quizzes, and then that makes 7.5%. The balance 2.5% is from your forum. There is a forum here. I think you're aware that there is a forum. Only 1 student have participated. There is another forum for today. Yeah, and this is overview on business analytics, and then the one is on business intelligence and data warehousing. Okay, now we will look at the article. Where is the article? Okay. This is the article. Okay. The article is about predictive analytics. How does predictive analytics save lives? It is an old article, 2012. The article is from Inform, Institute for Operation Research and Management Science. So it's about non-adherence of medication prescriptions in health epidemic in the US. So it mentioned look into figure 4. This is figure 2. So this is figure 3, and then this is figure 4. Yeah. So zoom into figure 4 and you provide explanation. Okay, this is the task. Okay, I'll share again the task that you're supposed to do. I think this, I'll show you in this format. The case study is you visit this site, you can have this link in your LMS, you read the article, and then in the article, you answer the following questions. What problem is being addressed by applying predictive analytics? What is the FICO medication adherence? You read through the case and then explain how prediction model. I usually give the case ahead. So before, now case number 2 actually will be in class number 4. So I'll give you a case earlier. You can read ahead. But anyway, I'll give you some time to read. Maybe this round I'll give you 40 minutes to read. So you have 10 minutes to read the articles, and then you have half an hour to discuss. And then and at the end of 40 minutes, I'll bring you back. So we just have a short discussion on the answers. And then after that, we will continue with our topic. I will go through with the topic quickly. And then the class is available. The iLecture is available in the iLecture in the LMS. Okay, any questions so far? Any question? So there are 30 of you. I will break you into a group of 5, 6 of you in a group. 31, okay, 30 of you. So I break you into a group of 5, a group of 6 at random. A group of 6 at random. You can get the questions at the LMS. Any question so far? Jamie, Hafizi, Azani, Mariam, Jason? Everybody?
No, Prof.
Okay.
No,
Okay.
sir.
Okay, so I will break you into group. So we will have some activity today. Now it's 8:10 o'clock in Malaysia. So we will come back at 8:50. You have 15 minutes, 40 minutes, 10 minutes to read and 40 minutes. You break up your own time. Finish your own time. By 8:50, we'll come back here. Okay. So hold on. I'll break you into groups. You will be 5 groups and then at random. Please join your group. Okay, welcome back to the main room. So we have 5 groups. The group 1 is Christopher Damirez, Hafizi Zainal, Lee Si Ying, Lam Jason, Nur Hasnina, Shafiqah Mazlan, Tommy Tiao. And then we have room 2, Lok Teng, Mariam, Nadira, and so on. Okay, which group want to share their points first? Which group? Which group volunteer? Let us. Any group want to start first? Group 1, Christopher, Hafizi. Or group 2, Mariam. Azani. What was your discussion points? What have you discussed on the questions that you? And let's go through the questions again. Where is the question? Yeah. Anybody?
Hi, Prof.
Yes.
Jason here from room 1.
Okay.
We for the first question, what problem is being addressed by applying predictive analytics? The room 1 thinks that the problem addressed was the non-adherence to medication prescriptions.
Okay, continue.
Continue to the following question, is it?
Yes, continue.
Okay.
Okay.
The following question is, what is the fecal medication?
Okay, the first problem. What is the problem being addressed by predictive analytics? What is the problem that you get, that you have discussed? What is the answer?
Non-adherence to medication prescriptions.
Okay, yes.
Yeah, that's all from
Okay. Okay, now let's listen to your question number 2.
Me lagi.
Okay. Oh, anybody else? Oh. Your question number 2.
Okay, I will answer for question number 1 for my group.
Okay. Yes, Castillo.
So yes, so the problem we discussed that first of all we are trying to understand what is not adherence to medication means. So it means not following the prescription given by the doctor. So after the doctor give you a drug, so you are not following completely. So we addressed that we understood that this only for patients who are being discharged from the hospital. So it's not for those patients who in the daily basis take the medicine. So it's those patients discharged. So that's what we agreed in our group. I don't know whether it's correct, but that's what we understand. So now the answer will be the problem being addressed by applying predictive analytics is non-adherence to medication prescriptions, which is a significant health epidemic in the United States. So predictive analytics helps identify patients who are at the high risk of non-adherence, enabling healthcare providers to intervene and implement targeted strategies to improve medication adherence. That's what we have.
Yes, great answer. That is what I expect. Okay, the second question. Which group want to do second question? What is the FICO medication adherence score?
I think we will. Oh, sorry.
Please.
Okay, listen.
Thank you, Ivan.
Okay.
So we are from group 2.
Okay.
So what is FICO medication adherence score? Basically, it's a way to predict the patient's intake on the prescribed medications. All right. So the information they collect is like their age, the gender, marital status, and how long they're actually living in the current demographic, along with their locations and diseases. And they based on a score which is from 1 to 500.
Yes.
All
So
right.
with that, then continue.
All right. So from there, that score is being developed and they break it down into the diseases. For example, conditions like asthma, depressions, diabetes, or high cholesterol, and so on and so forth. All right. So people who are scores that are higher, they are most likely to stick with their prescription. But on the hand, people who scored low are likely to continue the prescription, even for in fact like 6 months or lesser than that.
Okay, good answer. Okay.
And sorry,
Yes,
Prof,
continue.
to add on, so besides that, they also identify high risk patients, for example, that are undergoing a chronic diseases. That's number 3. And lastly is type of users that uses this score is mostly nurses, pharmacies, doctors, and also insurance agents as well.
Okay,
Thank you.
thank you very much. Next question. How is the prediction model being trained to predict the FICO medication adherence score?
Hi, Prof.
Yes.
So yeah, from group 4.
Okay.
So to train these FICO medications adherence score or similar prediction models, we should have a data set with patient information and then their medications adherence outcome. So this data set will be split into a training set and also a validation set. So machine learning algorithm like logistic regressions, decision trees, or neural networks are applied to this training data to learn the patterns and also the relationships between the patient characteristic and also the medication adherence.
Okay.
So once trained, the model can predict the likelihood of medication adherence for the new patients and assign maybe a continuous score. So this score will represent the predicted probability and also help to rank and then stratify the patients based on their adherence probability.
Okay, good. Question number 4. Based on the figure 4, how does the technique, what kind of technique is applied to on the generated results? What technique do you do? Do they do it, the graphs? Any group? Any other group?
Yes, sir. Yes,
Yes.
sir. So we have for
Okay.
number 4. So
Okay.
yes, so our group have a conclusion that the prediction model. Sorry, because this has not finished the question. Did the prediction model classify the FICO? This is the one that you're asking, sir. Am I right?
Yeah,
Did the
yes.
prediction model classify? So so we say the prediction model does not classify the FICO medication adherence score. Instead, it predicts the score as a continuous variable. So
No.
the model estimates the probability of a patient adherence to a prescription based on the input features and generates a numerical value representing the predicted adherence score.
Yes, good. Okay, the next question on the kind of technique that they use in figure 4. Anybody? Akshay, Azani, Hakimi, Tommy, or Shirin? Which group have not answered? Jamie, group 5, Ivan, group 4, group 3. Anybody
So
from
Prof,
here?
let me try. I came
Okay.
from group 2 actually. So
Okay.
we most of us had a very difficult time to address some of this question, right?
Okay, just
Especially
try.
this
Okay.
question, right? So
Okay.
because we are not really trained or coached yet on the kind of techniques that to describe the statistic data, right?
Okay.
So based on my reading and what I can understand, right,
Mm.
the kind of technique they use with the decile percentage and the distribution for this statistic, they try to go with a targeted approach of how to address each audiences within each decile. So instead of a broad brush method where you one size fits all for everyone, so they determine that certain decile requires certain kind of interventions, whereby they have defined the decile number 1, 2, and 3 is a higher risk segment. So you would address that with a very specific kind of interventions with the right persona and profile of all the patients within that group. That's
Okay.
kind of like our
Okay.
thoughts.
Actually, they graph the average days of adherence, okay, over a number of years, and then they use that data recording by millions of patients, and then to point out how the score relate to the problem and forecast how patients of the certain will act based on that data. Okay, on the last question, list some of the actionable decisions that were based on the prediction results. How the doctors and scientists can develop what are the actionable decisions that you can do from there. Okay, anybody? Last question.
Yes, sir. Our group
Yeah.
decided that these are the following, which pretty much we are following what is stated in the links or so. So it's number one, sending daily automated reminders via email or text message to remind the patients to take the medication. Simplifying drug regimes to reduce confusion and improve adherence. Providing information about financial resources such as co-pay cards or subsidized drug programs to help patients cover the cost of their prescription, and offering instruction in the patient's native language to ensure better understanding. That's what we agree in our group.
Okay, very good. So actually, you have an experience of discussion. It is a group study, a group case study. So it is routine in all MBA programs. You need to do discussion. So, and then that is the format of the questions that will come up in your. We don't have we don't have final exam, but if it is a final exam, that is the format. If it is a final assessment also, that will be somehow the format will be, meaning that they will give a case study and then you will have a few days to answer such questions like those. Okay, can we just continue? We continue with the topic that we will have today. I'll just go through some of the slides on topic 2. We are doing topic 2. I'll just go through some of the slides we have. I provided you with the slides. There are about 57 slides actually in the LMS, so I'll not be able to go through all today. I need to this. Not sure. Okay. Okay, everyone can see the slide, right? Okay, this is the development approach. So unlike, this is the common, okay, if you look into the normal engineering project will start with justification, we start with planning, we do business analysis, design, construction, and deployment. This is a traditional development project. We look at business needs, we look at project planning, functional requirements, we have functional requirements, we have system analysis, we have design, development, testing, implementation, and maintenance. But this is not the way that when we develop business intelligence systems. Business intelligence system, we don't do system analysis. Yeah, we do business opportunity, we do business analysis. Instead of doing system analysis here, we have system analysis, business need, project planning, functional requirements. Functional requirement meaning that when you have a project, you need to define what is the function of the system that you want to develop. But instead of defining the functional development and you doing system analysis, I think some of you might be coming from IT background or engineering background. Some of you might not. But basically, this is a traditional development approach. But when you develop in business intelligence or business analytics systems, it begins with business opportunity. And then the goal of business intelligence and business analytics is to support decision. So we need to have decision support strategy. And then we need to do project planning. We do strategic information requirements. What is the information requirements that you need to process? And then we do business analysis, because business intelligence, business analytics is about business analysis. Then only you will design, develop, test, implement, release the evaluation. Meaning by what it means by release evaluation, meaning that you will release first release version 1. We look back the business opportunity. It is an iterative process. So every time, from time to time, we will upgrade your system. Yeah. Okay, this is just introduction, and then when we develop a business intelligence, we will start with justification. We will do planning. when we do justification, we look into the business case assessment. What is the business case? Just now, when we talk about the case study today, we talk about the house with the about healthcare, who take preventive maintenance, preventive medication, and so on. So you look into business case assessment. We look into enterprise infrastructure evaluation. What is the enterprise infrastructure? Then only you develop the project planning. From the project planning, you will do your business analysis. Business analysis will have project requirement definition. You define the project requirement. Then you define what is the data analysis, what kind of data that you want to have. What is the application prototyping? We prototype the application. And another thing is metadata repository. Yeah? Metadata repository. Okay, what is metadata? Anybody else? I think anybody who have heard of metadata? Anybody have heard of metadata?
Data about data.
Yes. So what does it mean?
The information that prescribe what does the data is. What
Yes.
do, yeah.
Why do we need data about data in metadata in business analysis, in your data analysis? What in your data warehouse? Okay, there is a forum actually. If you look into forum in lesson 2, there is a question there. So you write your answer there, and then at least you will have out of this 8. You need to have at least 4 minimum requirement. Minimum you need to answer at least 4 quizzes. Yeah, you have a lot of quizzes. At least you answer 4 quizzes. There is quizzes that not quiz, forum. Yeah, I've given forum. One of the questions is about metadata. What does metadata relate to data? Metadata is data about data. It describes, it provides explanation, it provides detail, maybe the date, some definition of the data. Yeah. So and then you have database design. You also have data repository, metadata repository design. And then from this design, you will design and extract, transform, and load. So how do you extract the data? And then how do you transform them into a specific format, into your data warehouse, a specific format? And then how do you load them? Then only you construct the ETL development, application development, tools for you to do data mining. Basically, data warehouse is about data mining. And then data repository development, and then you will implement, and then you have your release evaluations. Okay, that is the basic of development, and then we go towards we are short of time, so I'll go very fast. I'll go through as much as I can. Okay, we look into business intelligence and data warehousing. So business intelligence is about using data for managerial decision making, or the managerial decision support. It supports decision. So we have gone through this topic last class. What is business intelligence? Basically, business intelligence is about descriptive analytics. When you look at it from the business analytics, business intelligence is descriptive. And then beside descriptive, you have predictive and prescriptive. Our case study was just now was on predictive analytics. Yeah. So what is data warehouse? Data warehouse is a physical repository. Physical repository where you where relational data. Today we also have NoSQL, but basically it is relational data. So you organize so that you can provide enterprise-wide cleans data. I mean, you need to cleanse data. At the ETL, before you do the ETL, we have cleansing data. We'll cover this next topic. Yeah, next topic. And then I think I've mentioned to you the data is non-volatile, integrated, and subject-oriented. So data warehouse is subject-oriented. You organize them according to the subject. So that because based on the subject, it can support decision support function. Yeah, it can support DSS function, decision support functions. So this is a historical perspective of data warehousing. I will not go through this, but basically there are 2 methods of data warehousing, which is Inman and Kimball. So characteristic of data warehouses, Data warehouses are subject oriented. It is based on subject. So you categorize them according to subject. They are integrated. Yeah, and then it is time variant. So it's place them by time. It is non-volatile, meaning that you cannot change the data warehouse, the contents of your data warehouse once it is placed. You cannot change. That is a timestamp. So for example, similar like when you do accounting, you would want to change, you need to post another entry to make the changes. So the end result will be changed, but progressively, the data should be always there. You cannot remove that. And then there can be summarized. It is not normalized. People, I mean, if you learn relational database management system, RDBMS, you will learn data need to be normalized. We don't want to have many to many relationship. But data warehouses, we don't normalize them. We just put them as it is. So what we did is we extracted them, we transformed them, and we load them, but we do not normalize the data warehouse data. And then it is supported by metadata, and then it can be web-based, relational, multidimensional data. It can be in the form of client server, cloud, and so on. So another thing that you need to remember when you deal with data warehouse, there is a term called data mart. Data mart, yeah, data mart. Two types of data mart. One is called dependent data mart. The other one is independent data mart. Dependent data mart is the data mart that is dependent on the main data warehouse. We have main data warehouse, and then we have a data mart. So, okay, this data mart is dependent of this data warehouse. So, for example, you have a data mart for finance. So this data mart for finance will extract the main data from the data warehouse. It will be processed at the data mart, and then at the end result will go back to the main data warehouse. So it has connection with the main data warehouse. Okay. Besides the dependent data marts, we have another data mart we call independent data mart. Independent data mart is not, it is totally out of connection it's also isolated from the data warehouse. You may develop a data mart to spin off a project. You may develop an independent data mart to do a special function, for example. Yeah, so it is separate. It's separate business unit. So that is independent data mart. Besides that, you have operational data stores. Operational data stores is an interim area for the data warehouse where you do operations. Yeah, and before it is being uploaded to the data warehouse. And then we have operational data marts, same thing. It is a data mart, but it is operational. Yeah. And then we have enterprise data warehouse, which is a data warehouse, a large data warehouse meant for the enterprise. We'll learn this later. And then metadata. Metadata describe the content of the data warehouse. Yes. So there are two okay, I will skip this. There are, okay, this is in general. This is in a generic data warehouse framework. You can see here, the data sources can come from many sources. It can be from your ERP, enterprise resource planning. It can be from your any legacy system. Yeah. Any of your legacy system. It can be from your point of sales, your system, your cash register, your point of sales. It can be from your other OLTP. OLTP stands for online transaction processing, meaning related to your POS or your ATM machine or any other OLTP. And then it also comes from external data, maybe from web and so on, other external data. So the process that we need to go through from the data warehouse, you need to go through what we call ETL process. ETL stands for extract, transform, and load. Extract, transform, and load. We will extract the data from the sources, and then we will transform the data into a specific format of the data warehouse. Your data warehouse, you need to integrate the data warehouse. So it must be a specific format that can be integrated. For example, you get data from Excel, you can get data from Access, you can get data from any other format. You need to transform them before you load them. So you will select the data, you extract data, transform the data, integrate the data, and load them into the data warehouse. With it will come the metadata. Metadata describe the data in the data warehouse. And then you can replicate the data warehouse for purpose of redundancy, meaning that for backup redundancy, you have data. Then you can have, these are the, what we call it, dependent data marts. Data mart for marketing, data mart for operations, yeah, data mart for finance, yeah, and other data marts. Yeah, so, but you can also have link from the data warehouse direct to the applications without going through the data mart. Meaning that if you have data mart, this data mart will process for marketing purpose. If you have operations for operation purpose, you have the operations data mart. But you can also directly deal with data warehouse straight to the applications. You can see applications here. You can have routine business reportings. You can have data and text mining. You have OLAP, online analytical processing, dashboard, web, or custom built application. In the middle, you have API and middleware. API stands for Application Programming Interface. Is this an interface? It can be SOA, Service-Oriented Architecture, web service, or any middleware that links between applications that speaks in one language to data mart that speaks in another language. So this is a generic model or generic framework of a data mart. Yeah. Okay, let's go through. Okay, there are different architecture of data warehouse. You have 3-tier architecture, 2-tier architecture, or 1-tier architecture. This is an example of 3-tier architecture. We have workstation here, application is here, and database server is here. So you have 3-tier, meaning that the client with its application, a client access through a workstation, the application here, analytics are here, and the database server is here, the whole thing. Or you have 2-tier architecture where application database server is in the same server, client is there. Or we can also have 1-tier architecture where everything is in a single server. So these are the issues that you need to consider when deciding which architecture you want to use. Okay, I'll skip this. Okay, these are the different alternative data warehouse architecture. We can have independent data marts architecture, meaning that you have source system here, you have staging area here, you have many independent data marts, and then you have, so this is independent data marts architecture. You can also design your data warehouse as, from independent data mart. So it is very atomic. So data coming from the sources will have a staging area where you do the extract, transform, and load. And then from the staging area, you will load them into the independent data marts. Independent data marts meaning that there is no data warehouse. All these are independent data marts according to different purposes, different objective, or different function. And then we have applications here, end user with these applications here. Or you can have dimensionalized data mart. So we have dimension. Okay, this meaning that this with this dimension, specific dimension, maybe marketing or this, and then we have link the data mart. The data marts are linked with each other. Yeah, so it is not independent. They are linked with each other, but there are many data marts. So we come with some conform dimensions. And then same goes here. We have source system, staging area, but these are dimensionalized data marts. Instead of independent, they are dimensionalized data marts. It comprises of data marts, but you dimensionalize them so you can break them. And then each one of them are linked together. And then you have an access applications here. Or you can have another architecture, call it hub and spoke architecture. We have a relational data warehouse here. We have dependent data marts like we showed the earlier slide. So we have source system here, staging area here, normalized relational data warehouse. It is normalized. So we avoid many-to-many relationship. And then we have dependent data marts here. Some of the data marts can be dependent, some data marts, meaning that some of the contents can be straight away in the data warehouse. So this is the most common hub and spoke architecture. This is corporate information factory, yeah, the most common. The other one is centralized data warehouse, where we have central data warehouse. We don't have data mart. We don't have data mart. We have centralized data warehouse here, relational data warehouse, and then we have source system here, staging area. We have normalized that relational database data warehouse. One data warehouse, one large data warehouse, centralized data warehouse, and then we have access, user access here. And then another architecture, the fifth architecture is the federated architecture. Federated architecture is we have metadata that link the different. We have here data warehouses. We have many data warehouses. We have many data marts. They are linked together through a data mapping metadata, and then end user comes here. So these are federated architecture, meaning that I have a data warehouse. Maybe Jamie Castillo have a data warehouse. Everybody has their own data warehouse. Some people have data marts, and then we use metadata to link everyone together, and then end user can access it using the metadata mapping, data mapping. So each and every one of these architecture will have different advantages and disadvantages. So you need to suit which one is based on your requirement. So you need, when we develop our system, we look at it just now when we covered our first topic, first slide just now. We look, when you need to look into your project requirements, your enterprise infrastructure evaluation, and then how do you develop? Then only you design your data. What kind of architecture you want to use? Okay, there are this is 10 factors. I will not go through this. Otherwise, we don't have enough time. This is extract, transform, load. I think we've covered this. ETL is extract, transform, and load. You can read on your own. And then I have my recording actually. My recording. And then two methods for data warehouse development approach. Two methods. Okay, one is called Inman model. The other one is called Kimball model. Inman model is the top-down approach, meaning that it is you plan ahead, you have enough capital, you develop your data warehouse. From your development of data warehouse, and then you break it some components into your independent data mass or dependent data mass, and you develop it top-down. The other way is data mart approach or bottom-up. You don't have sufficient fund to develop the large data warehouse. You start with data mart, and then you combine your data mart, and eventually you grow it up to become a data warehouse. Yeah, so the alternative is a hosted data warehouse, which is you put in the cloud. Okay, this is a data mart approach. This is enterprise data warehouse approach. Yeah. Enterprise data warehouse approach is the most expensive. Yeah, so I'll not go through the detail. And then how do you represent the data in your data warehouse? How do you put the data in data warehouse? You can, so one kind of model, we call it dimensional modeling. Dimensional modeling, we break them into schema, yes, into dimensions. Yeah, so we have star dimensions and also snowflake schema, star schema and snowflake schema. So dimensions, what are dimensions? Dimensions are your kind of measurement by product, by salespeople, by segment, by business units. How do you measure? How do you look at before measurement, you have this dimension for things that you want to measure, and then the measurement, what type. So you break the data according to the dimensions. For example, this is star schema. This is by time. This is by product. This is by fact table. This is by sales. This is by people, by geography. You break them. And then you can build relationship later. And then for this brand, you can break further, it becomes snowflake. Yeah, from unit sold, you break into line item, brand, category, you break further. This is snowflake. Yeah, this is star schema. Okay, comparing online transaction processing and online analytical processing. Online transaction processing are the things that you get from your transaction processing systems. Transaction processing system. I think some of you, if you don't have your MIS, transaction processing system. What is transaction processing systems? Transaction processing systems are systems that conduct the front-end systems that run the transaction, that conduct the transaction. You may have your automatic teller machines, ATM, that is a transaction processing system. You may have your point of sales, your cash registers, that is a transaction processing system. These are generic name for systems, that the front end system. Maybe you check in at your hotel. So that is the check in the front office system is a transaction processing system. You may have your banking system that you do transaction. So your banking system is a transaction processing system. So online transaction processing is it processes the transaction. So it captures, store data, and focus is to have efficient routine tasks. That is OLTP. When you talk about OLAP, OLAP is about analytics. It converts data into information for decision support. They are usually at the back end. Even if you, for example, you have CRM at the front end that deals with the customer, yeah, collecting orders and so on. And then you have CRM at the back end. We call it analytics CRM. The front end is operational CRM. It converts data into information for decision support. So you can have data cube, read down, roll up, slice and dice. You can request reports and so on. This is the back end, which is the OLAP. Okay, I'll go through detail. Okay, this is the difference between OLTP and OLAP. OLTP is meant to conduct or carry out day-to-day business function, business transaction, whereas OLAP is to support decision making. It is the back end. Yeah, how do you make decisions? So this is the differences between slice, dice, drill down, roll up, pivot, and so on. You'll learn pivot later when you do the data. Data is next week. No, next class will be about data and numbers, data, and then how do you pivot the data, meaning that you change the dimensional orientation of the data so that you can provide report, you can answer queries. Yeah. Okay, this is slice, this is dice, yeah, three-dimensional data cube. Okay, I will not go through this. You can read it on your own. And then data warehouse, the main thing that you need to look into data warehouse is scalability. What is the amount of data in data warehouse? How quickly will the data warehouse is expected to grow, the number of concurrent users and complexity of user queries. Yeah, so then administration and security. Data warehouse require high security administration. You need to have security and privacy, yeah, in data warehouse. The future data warehouse, they will be involved. It will involve web, social media, and big data. I think we have discussed big data in the first class. Or we have cloud, so software as a service, cloud computing, data lakes. Data lakes are not data warehouse, but they just put everything in together, so it become a lake. Yeah, and then the infrastructure, it's columnar and so on. Data lakes is an unstructured data storage, yeah, for big data. Comparing the data lake and data warehouse, we have a proper STL. It is structured, process. You have schema on the right, and then very fast retrieval and so on. But data lake is any data in raw format. We just chuck in everything together, schema on read, and then it is quite slow to retrieve because everything is there, and then designed for low cost storage. Yeah, you don't the cost for the data warehouse is for per storage is cheap. It's more expensive compared to, but data lake is meant to be big. It's meant for big data. It's meant for big data. Okay, actually we are running quite fast. Any question before I move into business performance management? Any questions on development of business and intelligence systems, development of data warehouse, the differences between data warehouse and data mart, what is independent data mart, what is dependent data mart, and then the different architectures of developing data warehouse and data marts, yeah, different architectures. And then I think you know what is extract, transform, and load. And then the differences between development approach, how do you develop, top down or bottom up? Enterprise data warehouse approach, which is Inman model, or the Kimball model, where you go bottom up. You build data mart and you build it up. You build it up to become data warehouse. Yeah. So any questions so far before we have half an hour left? I'm quite fast today. Any question?
Sir,
Yes.
yes, sir. This is really complex for my little brain.
Okay.
So business and intelligence means so we take all this data and make it in a very little pockets or to that level that you're having now, that structure, that is basically all the, in terms of business intelligence, that's where data is done.
Okay.
Because what I can see so many structures and complete.
Okay, business intelligence and business analytics are the same thing. Okay. Only that business intelligence focus on current data and past data. They just look into descriptive, what is happening today. But the business analytics, they look into the future. You look into how do you predict, how do you do prescribe, how do you make decision. Okay, how do we apply this business intelligence? We basically we have a data warehouse. We start with a data warehouse. So how do we develop a data warehouse? Data warehouse is a large data repository. It's not small. It's a large data repository. So where do we get this data? We get this data from many sources, from the web, from our transaction, daily transaction, from reports, everything. So even from our MIS, our enterprise resource planning, our CRM, everything data we bring in together. Okay, there is another two things. One data warehouse, one is called data lakes. Data lakes is we put everything without organizing, without structuring them. We put them raw. But data warehouse, we organize them, we structure them. How do we structure them? We have a process called extract, transform, and load. Meaning we extract them from the sources, we transform them into a specific format so that we can integrate and then we can relate one another. So we put them into a data warehouse. So that is a data warehouse. Okay, now you remember we have data warehouse. But sometimes data warehouse, it is too big. Because it is too big, it's difficult for us to process the whole large data warehouse. It will take time. What maybe you have you just want to have a little analysis of marketing, for example, or little analysis of your operations, or little analysis of your finance. But we don't want to look into HR. We don't want to look into all kinds of other things. So we develop a data mart. Data mart is an extension of the data warehouse, but it is these are called dependent data marts. Dependent data marts are an extension so that you can process this smaller size data compared to the data warehouse. Imagine data warehouse is a very huge repository. You extract some of it, and then so that you can process them. Okay, the goal of data analytics actually is to make recommendation based on prediction. Make recommendation based on prediction. How do you forecast? Yeah, so because from descriptive, you know what is happening today. Predictive, you will know what is happening tomorrow and maybe next year or next month. But you want to make decision based on what will happening in the future. So we have a we have to create model. We have to look into probability. We have to build relationship between one component to one component. We need to look into what they call hidden patterns like association, clustering, and so on. So we need to massage the data. We need to really process this data. So if you start processing a very large data, imagine how long it will take. We process today, tomorrow we will get. So a decision is not timely. So we take out some small information, we have data mart. And then we have another kind of data mart, we call it independent data mart. This independent data mart is a smaller data mart, but it is independent because I want to do a small project. Okay, it doesn't relate to whether what with the current nature of my business. I want to set up a new project. So The company gives me some fund. Okay, based on that fund, I do a project, a small project. So I will not be analyzing my data with the main data. It will be independent. That is called independent data mart. So this is what we done today, meaning that we have covered. Okay, I'll go through it quite quickly. Okay, this is the development. Okay, this is the difference between descriptive, and then analytics. And then these are the different data marts. Okay, you can see here. Yeah. So we have the data mart, we have the data warehouse, and so on. Data warehouse, we imagine very big data repository, but with some smaller data mart. Data mart are still larger than normal. Are still larger than the normal data center that we have. I mean, data that we keep for operational data, still larger. Yeah. And then there are different architecture we can put them, because depending on your capital, some want to break. We have client, we have application, we have data warehouse, data center at the back, or some can combine into 2 tiers, and then some need to have 1 tier. Depends on the funding that you have. And then this is the what I mentioned to you. You can have, how do you develop? You can have Inman model, yeah, or Kimball model, Kimball model bottom up, or Inman model top down. But you develop an architecture. How do you organize your data marts? It can be the independent data marts, meaning that every data marts are independent. Yeah, so you have a user that want to access data, they will get from the data mart. Or you can have dimensionalized data mart. You look into dimensions. You break them into dimensions. So this data mart is for this dimension, this data mart for this dimension, and then they are linked. They are linked, so you can summarize them. Or you can hub and spoke model. You have a data warehouse, you have a data mart. Data warehouse and data mart. This is the C below, data mart. Or you can have a large data warehouse without data mart. This is centralized data warehouse. You don't have data mart, everything is one repository. Or you can have many data marts and many data warehouse, but you map them using a metadata. Okay, that is development of data mart. Okay, this is the development approach. Inman model from top down, or Kimball model bottom up. So it depends on funding that you have, depends on your need. Where do you begin with? Some begin with operational, and then they will start the data mart approach and then develop up. Some, they plan ahead. Yeah, they plan ahead. For example, we have ChatGPT, they have large repository, they will plan ahead. They have enough fund. They will start from big, then break it down according to the functions and so on. I hope you understand better now, Jamie.
Thank you, Prof. Appreciate it.
Okay. Anybody else who have questions? Okay. So we need to talk about, okay, now is a different topic. It's about, now this is dimensional modeling. How do you develop the dimensional modeling and differences between OLTP and OLP? Remember, OLTP, online transaction processing, is the operational data. Operational data that's done up front. OLAP is the back-end data you need to use to make decision. Then it's an unstructured decision, semi-structured decision, for example. You need to use them. Okay, that needs to be between them. And then I will move into business performance management. Business performance management, this is related to your group assignment. Your group assignment will be about looking into KPI. You need to draw a dashboard. When you need to draw a dashboard, you need to measure. This is related to descriptive analytics. Usually business performance is descriptive analytics. You have done your business. You need to know, how did your business perform? How does your business perform all this while? Are we doing good? So your CEO can ask any of you, okay, are we doing good? Ask the finance manager, are we doing good? Ask the HR, are we doing good? Ask the operation, are we doing good? Can you answer whether we do good or not? Without a business performance management indicators, without an indicator, without KPI, Even profitability is a KPI. We make a gross profit margin of 56%. Oh, gross profit margin of 56%, meaning that we are good. No, we are making loss of 56%. So we are not doing good. So you need some kind of measurement that is called business performance measurement. It is a real-time system that alert managers what is your potential opportunity, what is the impending problem, what is your threat, so that you can react and collaborate. You need to know where you are now. Yeah, so you need to. So business performance management is about business process, methodologies, metrics. Metrics is about measurement, technologies used by enterprises, how to measure, how do you monitor, how do you manage your business performance. Without this, you will not be able to know where you are. So you need to be, there are 3 set of components. Yeah, these are, one is you need to know that one is the analytics process. Analytics process, you need tools, you need method. Yeah. So analytics process, you need tools, you need methods. One is a set of integrated closed loop management and analytic process supported by the technology. Number 2 is tools for the businesses to define their strategic goals and how do you measure and manage performance. Number 3 is the methods and tools to monitor your KPI. How do you monitor your key performance indicators? You need the key performance indicators, then only you know. Maybe you're from the top, you're a CEO, you have divisional managers, you have departmental managers, and then you have head of units, you have team leaders, for example. At the bottom of the team, you know, what is your KPI? You need to know. So how do you do that? We need to strategize. You define what is our mission, what is our values, goals, objective, incentive, and you create strategy map. And then we plan. How do we put our budget? Yep, our plans, operating plans, financial plan, and operational plans, forecasting, models, initiatives, targets, and then from your plan, you start performing, and then you need to measure. That's where you have our dashboard, performance dashboard. We need to know where you are now, and then what are kind of reports you need to use, and then what are the analytical tools. Then you need to act and adjust. In order to act and adjust, you need to interpret. Okay, this is my situation now. How do you see yourself? See, if I run a hotel, I make say my food cost is 25%. Is it good or bad? You need to interpret. Yeah, my food cost is 25%. Or cost of goods sold is 50%. Is it good or bad? You need to react. You need to interpret. You need to assess. You need to act and adjust. You need to know where you are. And then this is strategic planning. Focus in strategic planning. You need to conduct a current situation analysis. Then you determine your planning horizon. 3 years, 5 years, 10 years. And then you conduct environment scan. What is the industry like? Whether it's a growing industry. What is the market? What is your market position? And then you identify your critical success factors. You are looking into your GOP and so on. And then you complete your gap analysis. You provide your strategic vision, and then you develop your business strategy. And then from the business strategy, you develop your strategic objectives and goals. Once you have your strategic planning, you will develop your budget, financial planning, and then also operational planning. Besides financial planning, you need to have operational planning. Operational plan can be tactic centric, which is operation focus, or budget centric, financial focus. Yeah. So this is operational focus, meaning that how many customers you want to achieve, how many customers you want to increase. Or budget centric. Okay, what is the percentage of your ROI, return on investment? Okay. And then you need to monitor. How do you monitor? In order to monitor, you need to actually have a critical success factors. Yeah, so what are kind of measurement you need to do? And then you act and adjust. Yes, so like mentioned, okay, the percentage and so on. Yeah. So there is a performance measurement system. It's a system, it's a computerized system that enable managers to track the implementation of business strategy. Yeah. And then you have KPI. You need to have a strategic objective and you set your KPI, your strategy, target, ranges, encoding, timeframes. This is related your group assignment. Your group assignment, that is the case study. You need to develop a KPI. Yeah. And then this is your KPI. Okay, I want to look into balance scorecard. Balance scorecard meaning that this balance scorecard is developed by Kaplan. So it is balanced, meaning that we don't look at financial perspective only. We look at customer perspective. How does the customer rate you? You can see reviews. The customer doesn't like the product. You look into, we will learn later, say sentiment analytics. There are a lot of grievances the customer put in social media about your product. So that is customer perspective. And then the internal business process, internal business process, meaning that we look at the wastage. Maybe you look into Kaizen or Six Sigma, you can see we do a lot of wastage. We consume only a certain fraction of our operational costs, but a lot of it are spent on wastage. So the internal process, how do you improve your business process so it can be efficient and effective? And then learning and growth perspective, whether we send our staff for training, do they perform well? Do we have a lot of errors, a lot of shortcomings, a lot of complaints? And then finally, we look at financial perspective. The financial result, are we making profit? So this is what it means by balance. We look into all the not just the financial perspective or monetary perspective. We look at the customer, we look at how we grow our team, and then our internal business processes, our SOP, standard operating procedures, our routines, and so on. So we also have the Six Sigma. So you can later Six Sigma or lean management. Six Sigma look into defining a process. How do you measure a process? How do you analyze, you improve and control the process? Yeah. And then this is
Sorry, Prof.
Yes.
Can I interrupt you for a moment?
Can.
Yes, Prof. For example, in business economics, there is a way to test us, then we understand the class. In human resource, there is a process, then we understand the class, so there is a test, and then we know. Then I'm trying to look into how Prof is able to test us, or is able to qualify it or score us for this complex subject. How can you test us? Do you test us based on data, warehouse data management, data structure? How can you test us? How can I get results from, how can I learn? You know what I mean? Because in other cases, if you have it straightforward, these are look at geographical, look at the economy of this country, look at the understand the behavior in human resource and things like that. So it's basically but here I try to see how Professor Ackman is going to ask us to answer questions. And
the goal of business analytics actually is to make decisions. How to make decisions. So how do business managers make decisions? Okay, business analytics is to support decision making. Okay, in the case studies like this, actually, at the end of the subject, I think at the end of the subject, you will be able to use tools, business analytics tools, to support decision making, management decision making. So it is a very back end. Business analytics is a back end things. It is not like, say, marketing, which is front end. It meets the customer. Or HR, meet the staff. Yeah. So these are things that are for use by managers. For use by managers. Top level managers, strategic managers, middle level managers, or even not so much of operational managers. The business analytics are for managers decision making, managers that make strategic decisions. So whether you want to decide, and then when you it starts from descriptive. Descriptive is about where we are, and then predictive is what will be happening in the future, and then prescriptive is how does the manager make decisions. We haven't gone there yet. we have just started with balance scorecard. How do we measure our performance? We just started with data warehouses where we put our data. And then next class, we will learn about how do we use, how do we understand data? How do we understand data? The numbers, and then how do we understand data? And then we'll move on developing models, meaning that we can see, say, models like if you learn linear programming, for example, linear programming or multi-linear programming. So we will learn that if the customer, if this position of the, for example, you're measuring your profit, you know your break-even point. How do you calculate your break-even point? If there is a change of your cost, what will be, how do you, what will be your break-even point? Where will be the direction of your break-even point? And then how do you price your product? So it is more of decision making. We use business analytics to make decision, whether to invest, whether to embark into a new project, whether to carry out, whether to, how do you price your product? How do you buy? How do you maintain your costs? So your economic ordering quantity and so on. But it is not so much like accounting that it's simple. This is a little bit complicated. For example, we have three situations, for example, things that you can determine. We have certainty. We have things that are uncertain. We don't know what happened. And then there are things that are, say, we have risk. We will calculate the risk. So this is the subject of business analytics, meaning that being a CEO, being a top level manager, I think we covered last week, most managers decide by intuition. So intuitions are not data driven. Using business analytics, we use data to support our decision. We collect data. These data are not foreign. These data are data that within our organization. So how do we capture them? How do we organize them? And then we use them to make decisions. I'm not sure whether I'm answering you, but
Yes, sir. Thank you so much. I really appreciate that. Very clear, sir. Thank you.
yeah. Okay, because we don't have, next week we will not have any quiz, but the other week we will have another quiz. So every time we have quiz, we will use this application. For example, just now in your quiz, it's about medical, about healthcare. So how do you organize healthcare? How do you make decisions for healthcare? But maybe in next quizzes, we will see other applications, how do we use business analytics. Yeah. Okay, we have a few minutes left. This is strategic management, Six Sigma, and then I think you can read through this, and then that's all. Okay. Okay, tools that we use in the work course. Yeah? We will use Excel, and then, but Excel, you need to download the data and the analytics part. I will put up a video, and we will use R. From R, you can use metrics. And then from metrics, you can use simultaneous equation and so on. And then we will also use Monte Carlo. One thing about uncertainty, when things are uncertain, how do we make decisions? Things are totally uncertain. How do we make decisions? We can still do, because we fall back to what we call observations. We do observations, yeah? From the current situation, from the descriptive analytics, from the current situations, we see observations. From these observations, we can arrange them, gather them to become variables. Variables are variations that observations that varies over time. Yeah, we can see variables. And then some, even during uncertainty, things that are uncertain, there are things that you can see the variables. And then you can run a random program to generate random numbers. From these random numbers, you can see what we call it payoff. Payoff. We do this, this will be our effect. We do this, this will be our effect. We can create simulation. We can create simulation. And then how do we optimize? We can take into we can find an optimized situation. We call it optimization. Okay, we make decision based on the simulation, based on the optimization. So that is business analytics. Business analytics is about making decision. It helps you to make decision. It supports decision making. But the final decision is on the manager. Final decision is still with the manager. But how does the manager make decision? Hunches or intuition, or you dream, say sleep overnight, come back, make decision. How do you make decision? Business analytics use data to support decision making. We use data. So you will learn how to use, and then this data come from data warehouse. Data warehouse are big data, a large amount of data. So that is, I hope I answered you. Anybody else? So it's not like HR and so on, which are front end. These are back end. It is much more strategic. Hopefully I answer you, Jamie.
Yes, sir.
Okay. Anybody else? Mariam, Akimi, or Azani? Anybody else still confused? As long, I'm sorry, I'm very fast because we are short of time. But you go through my course because my video, I have a lecture, and then there are books provided. There are notes. Next week we'll look into more on data and numbers. Next week we look into data and numbers, and then it's more of descriptive analytics. Descriptive analytics is about, okay, we have situation today. So how do you measure your situation? Are you doing okay? Say, oh, Jamie, okay, do you call Jamie or James or how?
Sir, you can call me Jaime or Jamie. It's okay, sir. No problem.
Okay, okay. Jaime,
Yes, sir. It's okay. Thank you.
Okay. Okay. Your CEO asks you, is our business doing okay? What do you answer?
I would say that if they ask me, I need to check. Please give me a moment. I need to check. So then I will go into
How do you determine whether you are okay or not?
I need to talk to accounts. I need to talk to sales probably, and
Okay.
logistics and so on.
Okay, when we have business analytics, you can see, okay, this is the situation that we are today. This is the position we have. Descriptive analytics today. We can see, okay, predictive analytics. We can see, okay, this is the situation that would be happening tomorrow. Yes, we are okay today, but tomorrow we might not be okay. There will be trends or changes that are happening tomorrow. So we need to prepare ourselves, for example. That is business analytics. We are not tellers. We are not what you call it, astronomers, but based on the numbers or based on the data, we can see our present today, and then do we have enough funding? Do we have enough? Are we in the right position? For example, your company is moving to embark into a new project. I think, okay, you can tell. And then you can also look into your situation comparing to other players in the industry. Are we okay or are we not okay? So it is a very subjective actually when people ask you whether you are okay. Is our business okay? Say it's okay. Suddenly tomorrow something happened and then your company make loss. You say, oh, last week you said it's okay. Suddenly it's not okay. So
how accurate is that, Prof? How accurate? How reliable is that information?
We give it is pretty reliable because it is based on, okay, there are three situations. There is certainty. If you do this, this will happen. If you do this, this will happen. There is certainty because you know the situation. After this will happen. There is certainty. And then there is a situation where there is uncertain, totally uncertain. Tomorrow there will be an earthquake, for example, uncertain. But what are the chances that tomorrow will be an earthquake? So we have figures, we have data, for example, we have seismic measurement, and then you can run, and then you can, at random, you can say if this happened, how much will be the chances? There is some measurement, still there will be some measurement. And then there are risks and payoff, probability and payoff, meaning that we measure probability of certain thing happening, certain bad happening, and then if certain bad thing happens, how much will we lose? If we make good, how much will be our profit go? So, and then we measure. So when we recommend to the management, what will be the worst case scenario? What will be the best case scenario? The best case scenario, if you make this decision, the best case scenario you will make 100,000 profit. Best case scenario. If the worst case scenario, if you make this decision and it doesn't work out, you will lose 10 million. Which one do you do? Lose 10 million? You don't know.
Right.
Probability is between 100,000 to 10 million. 100,000 profit or 10 million loss. You still tell your CEO, you can make this decision. If it works out, we'll profit. Our payoff is 100,000. But if it doesn't work out, your loss will be 10 million. And then your CEO will think twice. Or the other way around. The worst case scenario is you will lose 100,000. But if you make profit, you will make 10 million. So that is the figures that analytics give.
Thank you, sir. My goodness.
These are doctors, what the doctors give you. How long will you, okay, I have this sickness. How long will you live? That is how they measure you. Yeah. Okay. Okay, thank you very much. We are 10 o'clock. Please watch the video. Actually, my video is also in my YouTube. It's actually coming from my YouTube. And then please download and install your R. I will also put up a video on how to use R basic, and then we'll use R for data analytics. Thank you very much. If there is any question, you can still ask before we adjourn. Any question? Sharin, Akimi, Omar? And please participate in the forum. Yeah, so it is not a difficult course, but it is not an easy course either. Yes, Azani, okay?
Okay, Prof.
Okay.
A lot of questions from Jamie just now to make me understanding a little more.
Well, I thank you, Jamie, because I require questions, because with questions I can answer better, I can explain better. Sometimes I don't know what to explain. Yeah. Okay. Thank you very much. We are 10 o'clock, 10:05. We can adjourn, and then we'll see you again next week.
Thank you, Prof.
Thank you, Prof.
Thank you, Prof.
Prof.
Thank you, Prof.
Thank you, everyone.
Prof.
Good night,
everybody.
everyone. Bye-bye.
Good night, everybody.
Bye.
Yeah.